We're on page 23 of your workbook, and we're looking at probabilities below a value, and this is for our normal distribution. So what we've got here is we've got an example, and it's our backpack example, so we've seen this one before. And again, our keywords are telling us that it's normally distributed, that they've got a mean of 3.3 kilograms, that they've got a standard deviation of 0.3. And here's the important bit. We want to find the probability that a backpack weighs less than 3.5 kg. So the first thing that we've got to do is we've got to write this down in notation. Okay, so my very first step is always draw my normal distribution on there, put the mean in the centre. We've got our mean of 3.3, and underneath that I'm going to write the standard deviation of 0.3. Now they've said find the probability that a backpack weighs less than 3.5. So on my scale there, 3.5 is going to be above 3.3. So I'm just going to place it around about here. And we want to find the probability that the backpack weighs less than 3.5. So I want that whole area below 3.5. So that's what it is that we're trying to find. So if I'm using my notation now, I'm going to write that as the probability that x is less than 3.5. That's what we want to find. So let's think about what we need to do. We need to convert this to our standard normal. So that's our next step. So we're going to convert that to a standard normal. And again, I'm going to draw my normal distribution. It's got my standard normal has a mean of 0 and a standard deviation of 1. And I need to find the point so that that area below is the same as the area below on my x graph. So that's my z graph, and this is my x graph. So we're going to figure out the formula. So we need our little formula, which is z equals x minus mu over sigma, and in this case our x value is our 3.5, so that's our point that we're interested in the probability. Take away the mean of 3.3 divided by the standard deviation of 0.3, and that is going to give us a z value of what have I just done? Get back out of there. Of 0.667, and I've gone to 3 decimal places there. Remember, the reason I'm going to 3 decimal places is that my probability tables go to 3 decimal places, so that's why I want to go to the same level of accuracy as the tables. Now we need to go to the tables themselves, and we've got to find out what it is that we're trying to do. So let me jump onto the next screen. So what we've got is, if we've got our standard normal with our mean of 0, there's our value of 0.667, and I want to try and find that whole area that is below 0.667. Now what we do know is if I just look at all of the area below the mean of 0, I know that area has a probability of 0.5. So really what I want to do is I need to find out how big this area here is between 0 and 0.667. So that's what I need to find out so that I can come up with my total probability. So we go to our tables, and on our tables we look up that little z-score of 0.667, and that turns out to have a probability